Okay, so we're going to do our study guide version A, second part of our video here, so systems of equations. Remember, a system of equations is just it could be two or more. For Math 1, we're only going to deal with two equations. And if we want to solve systems of equations, we have to have at least the same number of equations that we have variables. So we're going to have x's and y's and two equations. That's pretty much how all of these are going to go. So for each of these, identify the method of solution. Why did you choose it, and solve, and then check the system. So this is kind of a lot of work. I may not do that as thoroughly here all in the video because it would take a long time, but so y equals 3x minus 7, right, in equation 1, and y equals, zoom in here, negative 4x plus 21. So these ones, what I would recommend is what we did in class, right? Y equals this amount right here. So where I see y in the other equation, I know I can substitute that in. So if I rewrite this bottom equation substituting in for y, I'd have 3x plus 7 equals negative 4x plus 21. Right, so this method I'm using, or this problem, I'm using substitution. Right? And I'm using it because it's already set up pretty handily to do that. So now I just have to solve and get the x by itself. Well, it's not all I have to do, but it's the first thing I have to do. So I'm going to add 4 x's to this side. And I have 7x plus 7 equals 21. Subtract 7. And I end up with 7x equals 14. So the x is 2. I'm going to box that in, but that's not my whole answer. Right? I need to also find the y, right? We're trying to find the ordered pair. So I can take either equation. I'm going to take that one because it has no negatives in it, and I like the looks of that. So y equals 3x plus 7, and I know the x is 2. Right? So I'm going to take this and I'm going to plug it in for the x right there. So y equals 3 times 2 plus 7. 3 times 2 is 6. 6 plus 7 is 13. So I'm going to plug that in there. And my final answer, right, I should represent it as an ordered pair. So the x is 2 and the y is 13. Okay, part B. Here I see a system of equations where the x and the y are both on the same side of the equal sign, right? If I drew a line down there, the x and the y are on the same side. When I have that, we determined that most of the time we could use elimination and that would work really nice. So elimination is where I add my equations together. And if they're set up nice, something will disappear and I can solve. So first thing I'm going to do is look and see x and y are on the same side. So that means I want to use elimination. That means I'm going to add the equations together. So I'm going to check and see if I add them together right now, will something disappear? Right? So if I add them together right now, these x's would cancel out to 0. That's good. I'm going to ready to go right now. So I'm going to add the equations together. So 2y and negative 3y would give me negative 1y. Negative x and plus x, if I add them together, is 0, so it cancels out. 5 and negative 9 is negative 4. So negative 1y is negative 4. Divide by negative 1. The signs and the 1s cancel out. Here the signs cancel out. So y equals 4. Remember, that's not our final answer. That's half of our final answer. We need to know what the x is also. So I'm going to take either equation. Again, I'll just take the top one. It doesn't matter which one I use. 2y minus x equals 5. And the y is 4. So 2 times 4. Right? 8 minus x equals 5. I could get fancy here with what I'm trying to do, but I know the x has to be 3. right? 8 minus 3 is going to be 5. So the x is 3. So my final answer, 3, comma 4. So make sure when you're writing your ordered pair, right, x always comes first. Even though you found the y first, or sometimes the x will be on the left side in the solving because you happen to find it first, but make sure you list the ordered pair with the x first. All right. So here we have a decision to make, right? We could use substitution, and I showed this in class on our Delta Math day, right? There's y and there is y right there. So I could plug in the top equation, 2x minus 3y, and I know y is negative 4x plus 24 equals negative 2. So I substitute that in. Actually, I might do this problem twice. I'm going to do it once each way. So this is the substitution method. So now I have 2x, and I'm going to distribute. Negative 3 times negative 4 is plus 12x. Negative 3 times negative 24 is minus 72 equals negative 2. So I just distributed this through there. Now these guys have to get combined, so 14x minus 72 equals negative 2. Add 72 to both sides, and that'll go away, and this one will be adding 72 to negative 2 will give me a 70. And if I divide by 14, x is 5. That's a lot of work. And I got to finish it off though. That's not all the way done. So I have to take my second equation, y equals negative 4x plus 24, and solve. So I know the x is 5. So where I see the x, I substitute in a 5. Negative 5 times 4 is negative 20. Negative 20 plus 24. 24 minus 20 is 4. So using the substitution method, I see my answer. The x was 5, the y is 4. I'll put a star on it so we recognize that's how I represent my answer. And that's all totally, I think, as far as I can tell, totally good work. But I'm going to go ahead and actually look and see, like, what if we did this a different way? So this bottom equation right here, if I add 4x to both sides, the bottom equation would become 4x plus y equals 24. Right? All I'm doing is moving this negative over to the other side, make it positive. So now I have two equations, right? The top one and the bottom one. That could be set up nicely for elimination. That might make my life a little easier than what happened on the right hand side. So if I take that bottom equation right here and I move the 4x, I get this right here. And now I can eliminate the y's if I multiply this by 3. So I'm going to multiply that by 3. And I'm going to multiply all the numbers by 3. So this 4 would become a 12. And this 24 would become a little frozen there for a second, would become a 72. And then when I add the equations together, I get 14x equals 70, x equals 5. Right, so it's the same thing. So I just rearranged my bottom equation to have the x and y on the same side, and then I used elimination. And I don't know, to me, this is easier than all that substitution, especially when you have to distribute negatives and keep the signs straight and then combine like terms and then simplify and reduce. That's a lot of work. So you decide what works better. I would recommend, if you can use elimination like this over here, you do it. All right. You still have to find the y the same way we did right here, right? We'd take the 5 and we'd plug it in the same equation. All right, so I did this whole problem and then I realized I made a silly mistake at the very beginning. So I'm going to start this over and use what's probably an easier technique than I was using before. I'm just going to use straight up substitution. So if I look at this top equation, right, I see that amount I circled, that equals x. So in the other equation where I see an x, I'm going to put that in. So I can take this bottom equation, 2 times x, which is 1/2 y plus 1/2 equals, oops, forgot the, right, so that's 2x plus y equals 3. So the first time I did this problem, I got rid of the fractions first, and then I couldn't substitute easily, so I used elimination, and it was okay, but I made a little mistake. So this actually, typically we want to get rid of fractions first, but in this case it works okay, because when I substitute in and then I distribute, the fractions are going to go away. So 2 times 1/2 y just gives me 1y, plus 2 times 1/2 just gives me 1. So I distributed the 2, plus the y equals 3. So now I have 2 y's. So 2y plus 1 equals 3. Subtract the 1 from both sides. 2y is 2, and the y is 1. So y is 1. It's a good thing, but I'm not totally finished. I got to find the x. So I'm going to take this equation, bring it over here. To find x, I know that it's 1/2 of y plus 1/2. And the y I know is 1. So 1/2 of 1 plus 1/2. Half of 1 is 1/2 plus 1/2, so the total would be 1. So the x is, whoops, 1. So my final answer, the x is 1, the y is also 1. All right, so I'm hoping I can splice that into the last video, and then we'll do another video for the next set of problems.